In today's lesson, we are going to be looking at surface area. Surface area is a measurement for three-dimensional figures, and we're basically determining what the area is of every face. So you could think of it in a couple ways. You could think of it as if I'm going to, or if my 3D object is a box, and I unfold or unpack the box, it creates a net. We can see this kind of here with our cylinder and the net, cones, rectangular prisms, triangular prisms, square-based pyramid. If we think of our 3D object as a box or as a container, and if we unfold it and lay it flat, what does it look like? Based on what it looks like and how much space it takes up, that's the surface area. You could also think of it, we're getting close to the holidays, so if you're wrapping a gift, right? How much wrapping paper would you need to cover the entire outside without overlapping of your object or your 3D object? That amount of wrapping paper, if you were to lay that flat, that's the surface area of your object. So we do have our surface area formulas over here on the right, and it's broken up to basically describe what we're doing or what areas we're finding for the different shapes. So for example, the area of the base for our cylinder, pi r squared, we should recognize that as the area of a circle, which would be our base and our top. The lateral surface, 2 pi r h, is what we're dealing with when we're talking about this rectangle. And then the area total, 2 times the area of the base plus the lateral surface area, that's basically adding all of that up. So that's how the formula is broken down in this handout. We're given the area for each object or each part of our 3D object, and then the area total describes basically, that's the formula that we're going to use to find the actual surface area. So I would just make sure, if it helps, just underline or highlight the formula or the area total that you're working with, because that will tell you what formula you should be dealing with. And again, it tells you also what measurements to use when we're dealing with those shapes. So let's go through a couple examples and look at finding the area or the surface area of each figure. So here we have our cylinder. So the formula for a cylinder, or for the surface area of a cylinder, for the base, it's 2 times pi times r squared plus the lateral or the around the shape, so 2 times pi times r times h. 2 times pi times the radius. So again, this is the diameter. So the radius is 10 divided by 2, which is 5. So 5 squared plus 2 times pi times 5 times the height, which is 17. I would calculate this one at a time. I don't want to make any mistakes calculating or just make simple mistakes. So I'm going to do the one side first and get 157 plus 2 times pi times 5 times 17, 533.8. And then finally my surface area, I'm going to add those two together. And I should get 690.8 inches squared. So because we're dealing with area still, even though it's for a 3D object, because we're dealing with area is going to be our units squared for our the units. So that would be the surface area of our cylinder. If we look at our cube or rectangular prism, the surface area for this shape is 2 times the width times the height, plus the length times the width, plus the length times the height. So basically, we have 2 faces that are the same, and we have 3 different pairs. So this one lines up with the one on the other side. This one lines up with the one on the bottom, and this one lines up with the one on the other side over here. So basically, we have 3 pairs of different faces. Each will have their own measurement or combination of length and width and height. So 2 times, we have 19 times 13. If we say this is our length, our width, our height. Actually, let me go back and let's actually label our dimensions first. Width, height, length. In the end, it really doesn't matter as long as we have the correct combinations, but this will make it a little bit easier. So width times height, 4 times 19, plus length times width, 13 times 4, plus length times height, 13 times 19, and that's one giant calculation. I'm going to go through and solve each part first, again, just to avoid making small errors. So 4 times 19 is 76, plus 13 times 4 is 52, plus 13 times 19, 247. I need to add all that up first before I multiply by 2. So 76 plus 52 plus 247 equals 375. So 2 times 375 equals 750 centimeters squared. Because again, it's centimeters, and because it's area or surface area, it's going to be squared. For our triangular prism, again, the overall formula for this surface area will equal base times length plus A times H plus base times height plus C times H. So a lot of different letters here, and this is where it's going to be very helpful to look back at your actual formula page and look at the actual measurements to figure out what each letter represents. So if I look at my measurements, B refers to the height of the triangle, A and C refers to the 2 diagonals of my triangle, or sorry, no, B is the base of the triangle, L is the height of the triangle, A and C are the 2 diagonals, and then we have the length, or in this case they call it H, of the actual prism. So here, base times length, or B times L, is 12 times 8 plus A times H, which is 10 times 19, plus B times H, which is 12 times 19, plus C times 8, which is 10 times 19. And we can kind of see where this is coming from, right? The 10 times 19 is a rectangle. The 10 times 19 is the other rectangle. 12 times 19 is this base rectangle. The 12 times H, normally that'd be the triangle, and we divide by 2, but because we have 2 triangles, I can just cancel that out. Instead of multiplying it by 2 and then dividing by 2, they just cancel each other out. I'm going to go through and calculate each part individually, again, just to avoid making those minor errors. 96 plus 190 plus 228 plus 190. And now I can go through and add these. It should be fairly straightforward to add them all together. And we end up with 704 inches squared. For our square base pyramid, if we look at our formula sheet, surface area equals B squared plus 2 times B times S. So again, in this case, B is the base of our pyramid and S is the diagonal or the height of the triangle on the side. So in this case, 11 squared plus 2 times 11 times 16. Again, I'm going to do each part individually. 121 plus 2 times 11 times 16 equals 352. And then added together, 473 millimeters squared. So that's the surface area of my pyramid or square base pyramid. And lastly, for the cone, surface area equals, again from the formula sheet, pi r squared plus pi rs. R is our radius, 19 is our height, and s is the diagonal. So if I go to fill in my formula, I have pi times the radius, or 16 squared, plus pi times 16 times s, but we don't have s yet. What we should recognize though is that if I have my height and the radius and this diagonal, they form a right angle triangle. And we do have a formula for that right angle triangle. Oops. To help us find that missing side. 19, 16, and unknown. We do have a formula, Pythagorean theorem, that says the two legs squared, the sum of the two legs squared, so 16 squared plus 19 squared, has to equal that diagonal or that hypotenuse squared. So 256 plus 19 squared, 361, equals s squared. 256 plus 361 is 617. And at the end, I need to square root that number to get just the length. And in the end, I get 24.84 equals that diagonal. So that's what I'm actually going to be multiplying by, 24.84 in my formula. So we did have to use a small calculation to figure that out, which is okay because we should know or should remember Pythagorean theorem. I'm going to solve each part individually, or calculate each part individually. Get 803.84 plus pi times 16 times 24.84, 1247.96, and then adding it all together, 803.84 plus 1247.96, we get 2051.8 inches squared. So again, we did have to do a small calculation of Pythagorean theorem before we were actually to calculate the surface area. And it does help that when we're going through and actually trying to solve these surface area questions, that we're actually labeling our sides based on the images we see in the formula sheet, because then it helps us, or it's clear what numbers we have to substitute in to solve the actual equation. And just for reference, when I was going through and solving these, I was using 3.14 for pi instead of the actual pi button. So again, if you were using the pi button, your numbers may be slightly different, because again, the pi button carries a lot more of the decimal places compared to just 3.14. So again, just keep that in mind if you are using the pi button. But again, 3.14 works just as well. You just may have slightly different numbers, but it shouldn't differ too much.